Hey, what's up? Welcome back. In this episode, you'll learn a little bit more about... Hey, welcome to this three-part series about asynchronous programming with JavaScript. In this first episode, you'll learn about setTimeout and setInterval. These are two tools that the browser web APIs give us for working with timers. And we're going to also talk about the JavaScript event loop and start talking about how JavaScript executes asynchronously. In the next episode, we'll talk about promises. And in the final part, we'll talk about async and await. So right now we are in the thick of it with the Olympics for the that are in Tokyo. It's actually 2021 Olympics here. And what I wanted to do was go through the process of maybe building out some like a shot clock for basketball, or maybe like a countdown timer for boxing. We'll use these as we work on practicing our asynchronous JavaScript programming. I'm going to assume you have a little bit of experience with JavaScript, but not a ton. And it's a really common thing to be confused by how JavaScript promises work and how async await works. And I think it's really useful to first understand how the JavaScript is executing things asynchronously. So what I wanted to do was create here an index.html file. And in it, what I wanted to do first was show how the browser might block execution if it's doing a ton of work on the single thread. So JavaScript is asynchronous and single-threaded, and we're going to talk about how that works and how we can take advantage of that with our code, and what we might run into if we were to write some code that would block the browser and block the execution of the browser. So first, let's take a look on the Codist. There is an excellent blog post that has some really cool animated GIFs here. I would have probably created this call stack GIF a little bit differently. So at the very bottom, we have this function call to print square. So print square is executing, and then print square is added to the call stack. And then as we execute print square, we see this first line that has console.log with a square of n. And this is where I actually would have made the GIF a little bit differently, because square of n is really the next function that's being called. And we're going to wait to call console.log until the return of square of n. So then we call square of n, and that comes up here. Square of n then calls multiply. And when multiply is called, that's added to the stack. And then multiply executes. There's no real, as multiply is on the top of the stack, that's really the top of the stack is multiply. There's no function call for a times b. So that will return to this point. And then when multiply returns, that'll return here. And then console.log will be pushed onto the stack with that value, and then console.log will execute, and then console.log will return. Down here, there's another couple really interesting ones where we're talking about how callbacks are being added to a queue. In this example, they use setTimeout, and that's what we're going to talk about today is setTimeout. And so as your functions are executing, if there is a need to make an IO or an API call or some expensive call that's going to take a long time, we generally will do that as part of like it's almost like a background task. So we're gonna enqueue some job to run in a background task. So when we call setTimeout, we pass it a reference to a function that we want to call later, and we pass it some amount of time. And under the hood, there's going to be some reference to a list of setTimeout functions that need to be called and that delay. And as soon as that delay expires, there's some code that's written like inside of the engine for running asynchronous code. It's part of the web API, and it's part of the browser. It's part of V8, the engine that runs JavaScript. And that will say like, at the very lowest level, it'll wait for a signal that says that delay has executed and finished. And when the operating system sends that signal up that says, okay, 3,000 milliseconds is over, then the function that is related to that timeout is enqueued into a callback queue and executed. As soon as the primary thread of execution is done, it'll pick up that first task that's in the queue, and it will start executing the function from that point forward until it's done, like sort of running through a pass of the queue. So this is how sort of the event loop works. All right, so we've got this HTML page. What I wanted to do is start out with, let's say that we have a button on the page, and this button is going to say like go or something like that. And then we'll have an input box of type text. So this input box, maybe we want to like click the button go, and then we're going to type in a name of something. It's a little convoluted, but I'll show you what I'm talking about here. Then we're going to create a script where maybe inside of our script we have reference to that button. We're going to say btn.add event listener click, And when the button is clicked, we want to execute some function later. So we're going to pass in a function. So maybe our function is called, we'll say function do something. And inside of our do something call, we're gonna like make this make an expensive call, meaning when we run this do something function, it's going to do a lot of work to demonstrate how the browser might block if you did not have an asynchronous function or the tools for asynchronous programming. So we have this button, we're going to add an event listener. We tell it what type of event to listen for on that object. So here we're talking about the button go. I can use btn here because that's the ID of the button. So when the button go is clicked, we're going to execute some function. So here I can pass in do something. So do something will run when we click on the button. So we define this function, but it's not actually executing here. So then when we say let's make an expensive call, I'm just going to create a for loop that does a bunch of work. So here we'll say like maybe like var a is a function that takes in some number and it returns like n times n. And then we'll say same thing for b and c. And we'll change the signs of these, or we'll make them different operations. And then what we can do is we can make a for loop where we say for var I is equal to 0, while I is less than 10 million, 10 billion, something like this. 100, is that 100? That's 100 million, a billion. I plus plus. So we're going to do this. We're going to execute this for loop a billion times. And what we want to do is say we'll call A, and then we'll call that with the result of B, and we'll call B with the result of C, and then inside of C we'll pass in 1000, so that this for loop will execute this many times, calling these three functions. This should make it like an expensive API call. So let's go see, and then we can also actually, let's console.log like running, and then we'll console.log done here at the bottom. And I'm writing all of this code just in an inline script tag for an HTML page. And then I'm using the HTTP server NPM module that I've installed globally. You can go find this HTTP server node module over on NPM. And if you globally install this, then you can just run HTTP-server in the terminal, and that'll set up a local web server that'll just host those files statically. So that's what I'm using here to go to, so now I'm going to go to localhost 8080, and I'll refresh the page. And we're missing a closing semicolon here, I think, or closing parentheses. Button.add event listener is not a function. Add event listener. Did I spell that wrong? Okay, I must have. All right, so now what's going to happen is when we click the button, right? When we click on the button, it's going to call do something. So I'm going to actually click on the gutter here inside of the sources tab. I'm going to click on the gutter on line 14. When we click go, it starts executing do something, okay? And then it's going to console.log that it's running, and then it's going to console.log that it's done. So let's see what happens here. Okay, so it's running, and it actually takes a minute. And what you can see is that the debugger is actually sort of frozen here while it's running, because the browser isn't able to do a bunch of stuff until it's done executing. So there's some things that the browser knows how to do while it's executing, but there's a lot that you cannot do. Okay, so it's still running, it's still running, it's still running, and done. Okay, so that took a little longer than I wanted, so I'm going to take one of these zeros out. All right, so let's refresh this page. I'm not going to add a breakpoint, but I'm going to click go. All right, that was too fast. I'll put it back in. All right, so when we click on go, it starts running, but now notice that like, oops, okay, let's add another zero back. All right. So when I click go, I'm going to try to, so right now I can type into the text box, no problem. But if I hit go, while this is running, if I try to type in the text box, I can't even like click on it to add focus. So I'm clicking on the text box, nothing is happening. I'm hitting tab, nothing is happening, because as the browser is executing in that single thread to do our really expensive work here, we're not able to interact with the browser. Okay, so anytime we need to do something expensive, so for example, if we wanted to make an API call out to some web service, it takes anywhere between, I don't know, 50 milliseconds to 1 second in order to send an HTTP request to a remote server and receive a response back. It could even be longer if it's a slow running server, or if the server needs to do a lot of data crunching on the back end or is trying to send you back a ton of data. And so if we were to wait in the browser for a whole second while we were making API calls in the background to some service, then it would be really annoying because you wouldn't be able to interact with the browser while it was refreshing and loading all those things. If you remember back in like the 90s or something, when you would use a web page and all the images would sort of like sit there and load, and you kind of had to wait for a page to load, it was very annoying. But this is one of the reasons why we have asynchronous JavaScript and why JavaScript runs asynchronously. Now, you might actually want to do something like this where you're running some really expensive math equation that you need to run. How much is this? This is like, okay, so I think it's 10 billion times. So if you needed to run some set of 3 calls 10 billion times when you clicked a button, then you might want to actually put this into a web worker or to something in the background that can actually run it. But that's to demonstrate what happens when the browser's thread is blocking execution because it's in the middle of doing something really, really expensive. And that actually like sort of locks the browser while it's trying to figure out what it's doing. All right, so let's talk about setTimeout. So maybe we have like a p tag with the ID of, I don't know, update or something. Or let's call it scoreboard. And again, back to our Olympics example here, right? Let's say that we are in a boxing match, 3-minute rounds, or maybe we'll make our rounds 3 seconds or something. And so what we want to do is we want to update the scoreboard to say that we are now like fighting or boxing. So we'll say scoreboard.inner text is equal to fight. Okay, and then after some time elapses, we want the fight to be over and we want the fight to finish. And so what we might do is use this tool called setTimeout. Now, setTimeout takes a couple of different arguments. Usually, the most common way to call setTimeout is to pass a function as the first argument and then a delay as the second argument. So the delay in the case of a boxing match is going to be like the match duration or something like that. So let's say that for now, we're just going to pass in like 3,000. So this is the number of milliseconds that the delay should take. And so 3,000 millisecond delay, we'll say that our match takes 3 seconds basically. And then we want to execute some function after those 3 seconds are over. And so what we can do is we can say like, we can make a new function here called match over. And inside of our function, we could maybe update the scoreboard again and say stop or something. So scoreboard.inner text is equal to stop. Okay. And then we'll pass that as our first argument to setTimeout. So we'll say match over. So we don't want to actually execute it here. We're not calling the function, we're passing it as an argument. So at this point, like as we're executing our code, right? So we are setting the inner text of the scoreboard to fight. We're defining a function. We're defining a function that's not going to run it. We're just creating a new function. And then we're passing reference to that function. So I'm not calling the function here. I'm passing reference to the function. If I were to call the function, then setTimeout would say that the function is whatever the return value is from match over. So I would, maybe if I had like return 1 or something, then setTimeout would try to execute this number and it would fail because 1 isn't actually a number. But I don't want to pass the return value of match over. I want to pass reference to match over. And by passing reference to it, I'm saying, hey, here is a function that I want you to schedule to execute in 3 seconds from now. So in 3 seconds from now, run this thing. All right, let's go take a look at what this looks like. So I'm going to refresh the page and we'll see fight. And then in 3 seconds, it switches to stop. Okay, so you can see that here. So let's make this a little bigger. So I'm going to refresh the page again. We see fight. We're waiting for those 3 seconds. And while we're waiting, there's like a queue of all of the set timeouts, or there's some sort of data structure internally that has reference to the amount of time and to the function that needs to be called. And when that amount of time elapses, then that function is put onto a call stack queue. I'm sorry, into a queue that will be picked up by the event loop. So inside of JavaScript, it's always looking for new events that are being ready to execute. So it's waiting for you to click a button. If you were to click on a button, that's going to trigger an operating system signal that says like, oh, a button was clicked. and that will fire a signal that says, okay, take the function that was passed as the click handler for that button and add that to the callback queue, and then it'll start processing all of those things in the callback queue in order and pulling those off and starting a new thread of execution. So when you first load the browser, it's going to execute your JavaScript sort of top to bottom, and that's like the first pass through is like when you load the browser, it's going to take a first pass through all your JavaScript. Then anytime setTimeout or click handlers or any of these other things are happening, it starts to build up reference to all of these like chunks of work that need to happen. And every time the event loop finishes running through all the code, so for instance, when we load the browser and it finishes execution of all of this code, then it looks back at that event queue and says, oh, are there any other events that I need to run? Were there any setTimeout callbacks that finished? Were there any click handlers that happened? Form submissions, AJAX responses that we have all the data for? Any of those things that are ready to go, they'll all be pushed onto a queue and then processed in the queue. So if our match over function here, for instance, called another function, we could say like, I don't know, match over like check winner or something. And then if we had another function here that said like function check winner, and we could say console.log, the winner is Mayweather, right? Then as soon as the setTimeout occurs, we'll in queue match over into the callback queue, and then the event loop, when it finishes its tick, it will pick up that match over function, it will execute it, and then it's just going to keep executing any of the function calls that happen directly as the result of match over until it hits some async function, maybe where it needs to schedule something. So here, when we get down to setTimeout, we are actually executing setTimeout, and the function, the job for setTimeout is to schedule match over to run later. All right, that's probably good for setTimeout. You can also like decide that you want to cancel the timeout. So maybe you want to cancel the timer or something. So maybe if you were making like a cooking clock, right, for when you're baking cookies, and you wanted to set the timer for 15 minutes while it's in the oven, and you look in the oven and the cookies are actually like ready to go, but you want to cancel the timer, then what you could say is like const I is equal to setTimeout, and then you can say I, or like clear timeout, and pass in I. That's how you can sort of stop the timer before it finishes and executes this function. So you could manually stop the timer and do whatever you want. And let's make another part of the scoreboard here that we'll call timer. Very simply, I'm going to console.log line 1 and then setTimeout. Another way that you can write setTimeout is instead of passing in reference to a function, you can just anonymously define a function. Anonymous functions look like this, where you have the word function and then parentheses, and then you have the curly braces. This is the same thing as passing reference to a function. And here we'll again say like 3000 for 3 seconds. And then inside of our anonymous function here, we can say console.log line 2, like inside setTimeout. And then down here, we can say console.log line 3. Okay, so pause the video and think to yourself what order these console.logs are going to spit out. All right, so let's go check it out. Let's go check it out and see what happens. So if we hard refresh this page, we see in the terminal line 1, line 3, and then 3 seconds later, line 2 inside of the setTimeout. So line 1 went first, then line 3 executed, then line 3 executed. That's because when we're calling console.log here, that is not an asynchronous call. That is a function call that's happening like as part of this thread's execution. Same thing with line 3, but when we call, so we're calling line 1, then we're calling setTimeout, and setTimeout is going to do its thing and then keep going, and then like allow JavaScript to keep going. So setTimeout is saying, schedule this function where we're going to console log line 2, schedule that for 3 seconds from now, and then it's done. It returns, and the setTimeout is done executing. And when it's done executing, it moves to the very next line, console.log for line 3. It executes line 3, and then our first pass through the JavaScript when this page was loaded is done. So the event loop is empty, the callback queue is empty, everything is empty. And all that we have is there's a data structure internally that has the list of all the timers and the related functions. And when this timer expires, this function is added to that callback queue. The callback queue is checked every turn of the event loop sees, oh, there's a function I need to call because it expired that timer. It calls that function and prints out line 2. So again, we see line 1, line 3, then line 2. So that, hopefully that helps also clarify sort of the order of operations here. All right, let's add another tool to your toolkit called setInterval. So setTimeout lets you say, do this function after some delay. setInterval says, do some function after, or do some function after some delay, but keep doing it. Every single time that delay expires, do the function again. So here, instead of doing setTimeout, where it's just kind of like a set interval that after it expires, it runs the function one time and it's done. In this case, when we say setInterval, it's going to do something every 3 seconds. It's going to do something new. So in this case, let's say that our scoreboard board.inner text is like fight. And we'll say that like after every 3 seconds, maybe there's like a new punch that's thrown or something. So we'll say scoreboard.inner text plus equals punch. All right, so what's going to happen here is every time 3 seconds elapses, our scoreboard p tag, paragraph tag, is going to get a new word added to it. So we're using plus equals here. So we're taking whatever inner text was before and we're adding to it the word punch. So let's take a look at what this looks like. Let's actually make it 1 second and we'll refresh the page. So fight, punch, punch, punch. Ah, so many punches. Okay, cool. So in this Olympic battle, I think we're winning, right? 1 punch per second, pretty good rate. It would be even funnier if we made it like, okay, what about every 200 milliseconds? We French, boom, 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 boom. All right, so this is interesting, whatever, right? Okay, so this is one way that you can use setInterval, but a more common use case for setInterval is to use it as part of displaying some sort of timer or something. So let's update timer with some countdown timer. Maybe this is going to be like a shot clock for basketball or something like that. Okay, so we'll say like shoot. And maybe we have a variable for holding reference to what the current time is. So we'll say like var or like let time left equal 10 seconds. So we'll say that our shot clock timer ends after 10 seconds. And here we'll say every 1,000 milliseconds, so every second, we want to decrease the time that's left. So we're going to say, time left minus equals 1. So that'll decrease our number of seconds that are left by 1. And every single time that the timer goes down, we want to update that shot clock. So let's say timer.inner text is equal to time left. Okay? So we should see a countdown timer now. So it's saying shoot 10, 9, 8, 7, 6, 5, 4. Oh no, are they going to make it? Are they going to shoot? Ah, they shoot. And our timer just keeps going. Okay, so now it's like negative time, right? So negative 7 seconds. The game has been over now for 9 seconds. The game has been over for 10 seconds. Did they win? Who knows? But we could check check the Olympic scoreboard here in a bit for basketball. And it looks like, I don't know, maybe these are not going to actually happen until August 7th or 8th. Maybe that's like the ceremony that tells us when they won. But we have a problem with our shot clock, right? It should end at 0 seconds when the buzzer goes off. And so we want to stop after a certain amount of time. And so the way that we can do that is with clearInterval. So this, in the same way that you can sort of stop a timer, you can also stop an interval from running. And so when we are executing this code, right, we're going to set the inner text to shoot, creating a variable to hold the number of seconds that we have for time left. And then we're calling setInterval, and setInterval is going to return an integer value. And that integer value is reference to which function is running in that other data structure that we don't actually know about. It's just like sort of like a handle for the function that is going to like keep running, or for the interval that's executing. And so what we can do is we can say like const timer interval is equal to setInterval. So this gives us reference to the return value. And again, I'm going to console.log this timer interval at the bottom. And the reason is that, well, I wanted to just like see what that integer is. All right, so after we've already like set the time left equal to 0, we want to stop the timer. So as this function is executing, inside of the function that's executing, we want to call clearInterval, and we want to pass in the timer interval, okay? But we only want to clear the interval if we're down to the last second. So if we were to run the code right now, right? So if we execute this, we see that the timer interval is 1. 10 was printed out, but the timer isn't going down because the very first time that we executed this callback function, we cleared the interval and we like stopped the timer. So we only want to stop the timer after the time left is equal to 0, or like is less than or equal to 0. Less than 0 because, yeah, okay. Let's actually move time left down here. And then we'll say if time left is equal to 0, then clear the interval. And then we're done, okay? So let's refresh the page. We see 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, so now time left is equal to 0. Oh, also in the JavaScript console, you can hover over these variables and they'll tell you what their current value is. So time left is 0. The timer interval we logged out was 1. So we're passing in 1 to clear interval, and this is going to clear or like stop that interval so that it doesn't keep executing. We are going to decrease time left, and it will ultimately be -1, but that doesn't matter because the last time we updated our view, we set it to 0, and it should not update again. All right, so now our shot clock seems to be working. We have we'd say shoot, and then it's counting down by 1 second every single time, and ultimately it stops, and we are done. So let's run it through one more time without clicking on clear interval, and then we'll see kind of what happens here. 5, 4, 3, 2, 1. I actually don't know how long the shot clock is in basketball for the Olympics or whatever, but and then the other thing we could do is maybe we add like an alert that says like game over, right? So this is another tool that we could use. Game over is actually, oh, we put this so that it executed every time. So alert is a function that blocks the browser's execution. So when an alert is open, you should almost never use alert, but for demonstration purposes, it's nice. Okay, so what's interesting here is that the alert is also blocking execution, and you'll notice that the browser still says 1. That's because we haven't actually finished executing the JavaScript, and part of the browser's job is after we do all the JavaScript, then it's going to make the updates to the DOM. So even though we're setting inner text here, we've already executed this line of JavaScript that sets the inner text of that JavaScript or of that p tag to be 0. When we use alert, the alert blocks execution of the browser. And so when this alert is open, until we click OK, it's sort of frozen at this point. And there's nothing else we could do. Like we wouldn't be able to like interact with an input box or do anything else while this alert is open, because that alert is sort of holding reference to that sort of that thread of execution. It's not letting us do anything until we finish. And one of the things that the browser is going to do after we finish all the JavaScript is actually update the browser. So at this point, it can't update the browser until we click OK. So when we click OK, our current existing thread of execution, which was caused by the latest turn of the event loop where it was running that set interval because it timed out for that 1 second, as soon as we click OK, it's going to finish that thread of execution. Because we're clearing the interval, it's not going to run it again. And when it's done, it will also update the browser. So let's click OK. And now we see 0 there correctly. It's not continuing to count down because we cleared the interval. So hopefully that helps and makes sense. Another really common use case for setInterval is games. When you have a game that has some sort of game loop, like maybe you have a scroller, or you're building something like Flappy Birds or something where you need to sort of, or asteroids where you're flashing different frames of the game, or different, every time you have like a different tick of the game, you want to like check how many bullets you have, or shoot a bullet, or move a bullet along some axes or something like that. setInterval is one of the most common ways that you're going to run like that game loop. So you'll say, every 50 milliseconds, do a tick of the game loop. So something is moving along some axes or something, or scrolling sideways. And the way that you do that is like every single time the game ticks, you just move some object just a tiny bit. And when you move it a tiny bit and continue doing that every maybe like 10 milliseconds, the game will start to feel more fluid, even though it's just flashing. So that's kind of interesting. I think we're going to leave it at this. In the next episode, we're going to cover promises. So promises are pretty interesting, and they're one of the most confusing things about JavaScript when you're getting started, but we're going to dive into it in the same depth, and hopefully we'll clear it up for you. Thanks so much for watching, and we'll see you in the next one.